Okay, 9-7, dilations. Dilations is just this. The picture's just proportionally getting bigger or it's getting smaller. Same shape, not same segments by any means. Those are getting smaller. The angles pretty much are staying the same. So if I take a segment at the pre-image, remember pre-image is what you're starting with, and you're getting an image, which is your prime image. Do not mix up pre and prime, okay? So make sure that you definitely know the differences in those things. So if we're going from the pre-image to the image, what you do to figure out how they got that, it's a scale factor that they're multiplying everything by. How you figure that out is actually take the prime image lengths from a certain point, or you could actually take the length of the actual image itself, and you divide. You always put that prime image, the image, okay, the prime part of it, in the numerator of your fraction of your scalar. Your scalar is what you're multiplying everything by to get your image, okay? How do you do it? Put the prime values in the numerator, and you put the image values in the denominator. Okay, so in this case, from a certain point, we expanded the image to the pre-image to the image. So the prime part is 10. The pre-image part is 6. So this would be a 10 over 6, which is bigger than 1, isn't it?
Yeah.
Okay, so anytime your scale factor is bigger than 1, the image is going to get bigger. So that's what you got to look at. Is my image getting bigger, or is the image getting smaller? And that should tell you how your scale factor should look. Okay? So in this case, we got 10 over 6. I don't need to go any further than that. Let's take a look at just reading a problem. In a dilation, the prime, C to prime is 4, and C to the normal, the pre-image is 20. Which one goes on top? 4. 4 over 20, that's going to be a scale factor of 1/5.
Yep.
Okay? So you're going to have matrices as well. Remember how we do matrices? X, Y, X, Y, X, Y? Yes?
Yes.
I think we'll get to that here in a second.
See.
So you can plot your coordinates, put them in matrix form, and put your scale factor out in front. And that will give you your image matrix. So you're going to have to do that. Let's see what's on the next page. Here's a construction. I'll just kind of walk through this real quickly. Draw and label LMNP, which is this down here, LMNP. So the image got smaller, right?
Yes.
Yeah. So the pre-image got smaller to the image. So is my scale factor less than 1 or greater than 1? Less than 1. All right. It says construct a dilation of LMNP with point L as the center of dilation. Okay, and the scale factor of 1/2. So all they did was they took their protractor, okay, and took it in half, and then just drew the lines. That's all they did. Okay, pretty simple because they have measurements on it.
It's like the construction.
You could take a ruler though.
Yes, you could take a ruler, but that's not how we do construction geometry.
Is that a bisector? Kinda.
Oh, well, actually, you know what? That's a great question.
Good work.
That might be something you have
I don't like that.
That might be something you have to prove.
I don't want to prove that. Oh, come. He's going to put that on the quiz.
Draw and label triangle PQR. Then construct a dilation of PQR with P as the center of dilation and scale factor 2. So, is my pre-image smaller than my image?
No,
No, bigger.
It's
double twice the size.
Twice the size.
It's
I
twice
asked,
bigger. Twice
I
the size
asked,
bigger.
Yes.
is my pre-image
Oh, it is
Smaller.
small.
Divided by 2 the size.
Hold up.
pre-image is what you're starting with. That's why it says.
Oh, okay.
That's why it says pre.
I thought the
Pre-image before
like,
post means
like not
after.
post.
Okay.
Not post.
Except they don't use post. They just say image.
Yeah.
That's what's
Like,
weird about this.
did the block.
Is the
Okay,
second-
so the construction is just, yeah, your image is gonna be twice the size, right?
Is the second image, like, say there were two things, like if you're moving a shape, so you start out.
Moving is transformation.
I know, but like if it's you have ABC and then you move it to ABC prime, that's the image. If you move that to like ABC double prime, would that be a post image?
No, it's still, no. Yeah, you gotta call them by their prime, single prime, double prime. Stop talking. Alright, so let's talk about the matrix stuff.
One column, one.
So this is x, y, these are coordinates. And scalar is 3, so is the image bigger or smaller?
Bigger.
Bigger.
Thank you.
3 times.
Alright, right. So they take 3 times each of these. What do I get?
0. 6. 15. Negative 10.
Negative 10.
I don't know. That's all the 5.
3 times
I
negative
wasn't
2.
paying
3 times
attention.
5?
12 and negative 3.
Thank you.
I was close. Okay.
Okay, so we don't even need to know this. This is just showing what they want up here is 3 times 0, 3 times 5, and the answers were down here. That's all that is. That's why I don't like using this. Okay, so that's how you set up a scalar, your dilation times a matrix to show how you can use matrices to do dilations, okay?
Yep.
And then you would plot those points on a graph to show where they're at. Right?
Yep. Easy.
Easy peasy. Okay, let's do this one. Vertices of quadrilateral ABCD are negative 3, 0, 0, 6, 3, 6, and 3, 3. Alright, so that's the pre-image. Use scalar multiplication to find the image of ABCD after dilation with its center at the origin and a scale factor of 1, 3. So, we getting bigger or smaller?
Smaller.
Okay, so let's plot these points.
Smaller.
Negative 3, 0
Smaller.
is A.
0,
B is a 0, 6.
Over 3 up 6.
C is at 3, 6.
Over 3 up 3.
D is up 3, 3.
Okay.
You can read Tyler.
Shut up.
Whoa. Hey, it's a kite. No.
Okay, so scale factor is 1/3. What do we get?
Negative 1, 0, 0,
0, 2.
2, 1,
Yeah?
1, 2, 1, 1.
Yep.
Let's graph those. Negative 1, 0.
Good work.
0, 2. This is A prime.
1, 2,
Prime.
and 1, 1.
2.
And then,
Oh, that's just freaking sweet.
and then over 1 up 1 is 1, 1.
That's a baby kite.
There you go.
Good.
That's the visual of dilation getting smaller.
That's a good.
That's how you do it. This will be on the test, certainly. I'm not seeing the test yet, but I can't believe that would be on the test. Got it?
It's easy to go.
Excellent. Your homework assignment.
You should mark it just so you can write that.
This is on page 629, 3 to 29, and 33, 39.
Should have like 20.
And if you don't be quiet, you can do all of them.
I would have put 1,000.
Begin.
30.
Talk about math.
Math.